Salient features of kinetic energy. Now we know kinetic energy is defined as half mv square. From this expression, we know that kinetic energy in short form is Ke. So kinetic energy is directly proportional to mass of the body, and kinetic energy is directly proportional to square of the velocity. It means that if the mass of the body is doubled, let us say m becomes 2m and velocity remains the same, velocity is v, then what happens to kinetic energy? It becomes half into 2m v square. So it becomes mv square. So the kinetic energy also doubles. So we say that if mass is doubled, what happens to kinetic energy when mass is doubled? Kinetic energy also doubles. In the same manner, if we keep the mass as it is and increase the velocity of the body is doubled, what happens to kinetic energy? It becomes half into m into 2v whole square. So that means half into m into 4v square. So this is basically 2mv square. So the kinetic energy has become now 4 times, because the kinetic energy is half mv square, whereas here it is 2mv square. So it has become 4 times. If velocity is doubled, kinetic energy becomes 4 times. If the velocity is halved, that is, if velocity becomes half v, then what will happen? If v becomes half v, then kinetic energy becomes half m into v by 2 whole square, which is half m into v square by 4. So it becomes 1 by 4 half mv square, which means if velocity is halved, that means it has been made half of its original velocity, then the kinetic energy is 1/4. In the same manner, if mass is halved, what will happen? Its kinetic energy also gets halved. Mass is halved. Halved means it has been made half. Then kinetic energy is also halved. These are some of the important conclusions we derive from the equation of kinetic energy. And we also can say that by doubling the velocity, it has a greater effect on the kinetic energy of a body than doubling the mass. Why? Because velocity is in the square, the expression. Since the kinetic energy of a body depends on its mass and velocity, we say that the heavy bodies moving with high velocities have more kinetic energy than the small moving bodies of small mass. So we say that the heavy bodies moving with high velocities have more kinetic energy, I'll use the short form Ke, than the slow moving small bodies. Small body means small mass. We can actually explain this with an example of blacksmith and goldsmith. Blacksmith uses heavy hammer, whereas goldsmith uses a small hammer. Why? Because blacksmith deals with heavy metals, the steel, things like that, with a heavy mass, whereas goldsmith uses the gold, which are having a small mass. He does a very ornaments with small masses of gold, whereas blacksmith makes things with heavy steel, with a bigger dimension, bigger quantity of mass. Other thing we also understand here is, when a driver is driving a hilly road, he increases the speed. Please note that the speed and velocity are used interchangeably in these chapters. Driver increases the speed on hilly road compared to when he is driving a car on a flat road. Why? Because on a hilly road, you will have force of gravitation also acting on it, in addition to friction of the road and air resistance. So more work has to be done on a hilly road compared to a flat road. So the driver increases the speed of his car on approaching a hilly road so that it can give more kinetic energy to the car so that it may go up against the force of gravitation. So he increases the speed so that kinetic energy also increases. So it can go on the slope of the hills smoothly. On a flat road, you will have only air friction, friction of the road and air resistance. Whereas on the hill road, you have air resistance, friction of the road and in addition to them, a force of gravitation. And that is the reason he increases the speed by which kinetic energy is increased. So, the car can move without any problem. And the kinetic energy is denoted as Ke, and it also in some cases denoted as Ek. Energy suffix K means kinetic energy.